This video is going to cover Chapter 6, Section 4, Part 2, so the end of the notes that we took previously. A quick refresher on what we talked about in the first part of 6.4. The most important things were the dot product. So if I have u dot v and u was 3, -4, and v is, let's just say 1, 2, that to find the dot product, I multiply the first times the first. So it'd be 3 times 1, and then I add to it the product of the second times the second, or -4 times 2. And I'd get 3 plus a -8, or 3 minus 8, which is -5. Then we talked about the fact that the dot product can be interchangeable. So if it says u dot v, it's the same thing as v dot u. If we had a scalar multiple like 3 times u times v, that we can do that in any order because that scalar holds the same weight as the dot product. So we could do u dot v dot 3 or 3 dot times v times u, any of those. And then we also talked about how to find the angle between two vectors. So the angle between can be found by doing the cosine of theta equals u dot v, or the dot product of u and v, over the magnitude of u times the magnitude of v. So if I actually go back to the example that's over here, okay, if I wanted to find the angle between 3, -4 and 1, 2, I would find the dot product of those two, which we already found was -5. And then I would find the magnitude of u. So square root of 3 squared, which is 9, plus -4 squared is 14, square root of 25, which is 5, times the magnitude of v, which would be the square root of 1 squared, which is 1, 2 squared, which is 4, and square root 5. And then I would let my calculator do the work for me. I would do cosine -1, open up my parentheses, -5, close, divided by, open the parentheses, 5 times the square root of 5, close the parentheses, and I get that theta is 116.56. We're going to round that to the nearest tenth, which was 116.6. And then we also talked about how we can actually plot those vectors so that we can see if it matches what it says. So if I have a vector that's 3, -4, I'd go right 3, down 1, 2, 3, 4. It's approximately there. And then if I have another vector that's 1, 2, I'd go right 1 and up 2. That's my other vector. And that definitely appears to be bigger than 90 degrees, which makes sense with our 116.6. All right, so that kind of catches us up to where we are now, which is finding the dot product given the angle. So now we're going to work in the other direction. We just said that the cosine of theta equals u dot v over the magnitude of u times the magnitude of v. So now let's consider that we actually have the angle and the magnitudes, but what we're looking for is the dot product. Then we can simply, if we had multiplied the bottom by both sides here, we would have gotten the magnitude of u times the magnitude of v. Over here would cancel out, and over here I'd get magnitude of u times the magnitude of v times cosine equals the dot product of u and v. So questions will look like this. Find u dot v, where theta is the angle between u and v. So we just said that the dot product would be cosine of theta times the magnitude of u times the magnitude of v. And all I got to do is plug in. So cosine of 5 pi over 6 times the magnitude of u, which is 5, times the magnitude of v, which is 4. So I'm going to get 20 times the cosine of 5 pi over 6. Now, if this was a question that had an angle like this does, that is on my unit circle, then I'm expecting the answer to be exact. So if you think about unit circle, that 5 pi over 6 is going to be in my second quadrant. All of the over 6's are root 3 over 2 and 1/2. And if it's in the second quadrant, the x is negative. So the coordinate point there would be negative root 3 over 2 and 1/2. The cosine of that would be the x value, which is negative root 3 over 2. Simplify this by reducing it, and I'd get negative root 3 times 10. Or negative 10 root 3. If this angle was not on my unit circle, if it wasn't an over 2, over 4, over 6, or over 3, then I would use the calculator to find it and then multiply it times 20. The last thing that we're going to talk about in this section are orthogonal vectors. So two vectors that are perpendicular, or vectors that meet at a right angle, are called orthogonal. And two vectors are orthogonal if and only if the result of their dot product is 0. So how we'll be testing to see if two vectors are perpendicular. Obviously, just graphing them out is not enough information, although it would be helpful to check our work. The way we'll do it is by finding their dot product, and if it equals 0, then we know that they're orthogonal. So you can also test to see if two vectors are parallel, and you can tell that by the relationship between their component form. This says that u equals k times v, which means that one would be proportional to the other. Or you can do u1 over v1 equals u2 over v2. Probably the most easiest way to relate it to what we know about parallel is that two lines that are parallel have the same slope. So if you were to look at u1 comma u2 and v1 comma v2, remember that the first one is your change in x and the second one is your change in y. So if we actually find the slope of this line, we'd be putting u2 over u1. The slope of the vector, sorry, not the line, of the vector for the second one would be v2 over v1. And if these are the same, then they're parallel. So it's probably easiest to do this, but you can also take 1 over 1 and 2 over 2 and see if they match. Because of the properties of proportions, it would still work. So example 5 says determine if u and v are parallel, orthogonal, or neither. So the first thing I'm going to do is look to see if they're parallel. If I were to do this in component form, it would be 2, negative 2. This in component form, negative 1, negative 1. So if I take the y, change in y, negative 2, and put it over the change in x, I'd get negative 1 here. Do the same thing here, change in y, negative 1, change in x, negative 1. I get 1 here. These obviously don't match, so they're not parallel. Hopefully, from prior knowledge, you recognize that those are opposite reciprocals of each other, which would make them perpendicular. But the other test would be to find the dot products. So the dot product of u and v, or using these two, would be first times first, 2 times negative 1, plus second times second, negative 2 times negative 1, and that's negative 2 plus 2, which is 0. And because the dot product is 0, I know that these are orthogonal. If it was neither, obviously I would have said neither. So you want to look at their slopes and compare if they're parallel. You want to look at their dot products and see if they're orthogonal, and then if not, they're neither. All right, that wraps up section 6.4, so you can spend the rest of the time working on your assignment. Have a great day.